Okay. Hopefully you guys can hear me and see me. Oh, let me check. Hold on one sec. Let me make sure this screen is up front. Can you hear me and see me? This time I think I've got the mic set up right. So it's not my, can you hear me and see me? Across the room camera mic, I think I've got the actual mic that I'm got on me. So it's not my, can you hear me and see me? Volume is low. Okay, anyone else experiencing a low volume? Got on me. Do what I can. Can you hear me and see me? Volume is low, but it's awfully difficult to raise the volume with YouTube. I don't know why they do this. Volume is low, but it's awfully difficult to raise the volume with YouTube. I will do the best I can, guys. Yeah, I see that the volume's a bit on the low side. I wish that YouTube would be better about this, but I can, guys. They really make it difficult. I wish that, and if I go too high, what ends up happening is that I'll end up frying the vocals on the other side. I wish that so if I go too high, let me try a little bit. Push it up just a tiny bit more. So try that. Ooh, that's pretty hot. Just a tiny bit more. Check, check, check. Check, check, check. Is that a little bit better? My frying vocals? It looks like I'm frying them. Is it getting distorted? Check, check, check. Is that a little bit better? That's my problem. Is that it's just this hairy edge between getting distorted, being too loud and not loud. That's my problem. Is that it just hopefully that works. I think I've kind of got it about as good as I can get. That's my problem. Is that it just hopefully that works. You guys, are you guys hearing an echo? As good as I can get. That's my problem. Is that it just I have no idea. You guys, are you guys hearing an echo? As good as I can get. That's my problem. Let me listen. I have check. No idea. Are you guys hearing an echo? As good as I can get. That's my problem. Let me listen. I have check. Wow. Are you guys hearing an echo? As good as I can get. That's my problem. Let me listen. I have check. Wow. Are you guys hearing an echo? As good as I can get. That's my problem. Let me listen. All right, let's see if this is any better. Is this better, guys? It looks like I had a rogue screen up that was actually feeding the live stream back into my OBS. Yes, can you guys hear me now? Wow, that was wild. Yes, everybody's, oh, there we go, okay. Good night. Yeah, I had no idea that I have you know, I'll take a moment to mention this. Patreon has changed everything. They just changed everything. And they don't tell anybody, they just do it. So I came back and everything's changed. Now, when I have a Patreon stream up, it automatically turns on. So I immediately went to Patreon because I just knew it had to be Patreon. And it was. They just, I don't know what they're doing, but they're not making me happy. So thanks for dealing with that for a few moments. You know, this is what happens when you're a one-woman show. You just got to kind of flow with everything. All right. Let's hope that everything else moves smoothly. Okay. Goodness, there's been a lot of activity on the sun. There's been, and I am, you know, still trying to come down from AGU. So, you know, wow, it's just a lot of stuff going on. Okay, so thanks for dealing with that, guys. It looks like everything's better. You guys can hear me now. BBC quality now. Well, I don't know if that's a compliment or not, but at least it sounds everything is fine. I like her more knowing that she has a temper. Okay. Yeah, some of you in my Patreon family might remember. There was one time I got caught with an expletive I didn't set it out to the public, but my Patreon family remembers that, and it was an outtake, and yeah, That was quite amusing, embarrassing, but you know, everybody has bad days. Okay, so this was another fun technical thing. Let's get into the forecast. What I plan to do is I plan to do a bottom line up front type forecast where I just try to rush through as much as I can and get you to the 5-day outlooks. And then we can do a deeper dive and go into some of these things. So I do have a nice little roll behind me that I've had, that I actually did a snapshot last night. I went ahead and left the words in for those of you who you know, that might benefit. I'm just checking to make sure that nobody is, yes, there's a broadcast right now, Alan. Yes, I am live. Okay, so that'll work there. Okay, so let me start the forecast. Let me start the streaming so you can see what's going on. And if it will go, please go. Okay, there we go. So what we're mainly looking at is going to be region 3514. That is really where a lot of this stuff is going on, but there's a lot of other activity all over our star. And sorry about the floating numbers here. I don't know why they didn't get taken out, but we have not only this set of active regions, and as you can see, it's a cluster, and that's going to be a theme when we do the deep dive. We'll talk about these clusters that are popping up where you're getting lots of active regions really, really close together. It's an indicator of something for us. And so we'll be talking about this. We'll be talking about this filament here. We'll be talking about this coronal hole and some activity around it. We'll be talking about region 3516. All of these regions have been, and all of these areas have been very, very active this week, okay? So we'll start off with with basically the very first storm that was launched. It was going to be from this region. It's from an earlier solar flare. This was an M-class flare. I forget exactly what level it was. We can do that on the deep dive. But you'll see it here, wham, right there. And did you see the dimming? All that dimming region right there? That is the first solar storm that has a partially Earth-directed impact. And then if you notice, right up here, and I could back up just a smidge. Whoop. Oh, that doesn't back up. Hello, I hit the wrong button. Maybe just play it. I'll play it forward again, and I can make sure I hit. There's that one, and then you see this whoosh. Okay, that is a filament. Okay, that also erupted and went somewhat north of us. So let me back up a little bit so you can see. Right, that almost happened simultaneously. You got this big M-class flare that fired off, and then you had this filament. And not the whole thing erupted, just part of it. Okay, so I'll play it again. That's that, and then whoosh, okay? So when we actually look at coronagraphs, here is the very first, so for those of you, this is an Earth-directed coronagraph. This is SOHO, LASCO. You're looking, this is the raw intensity images. This is actually the difference image that really, it basically makes the features in this stick out a lot more, okay? So what you see is you see that southward, that's the eruption from here, from 3514 during that big M-class flare. And then you have this, you know, a slighter, larger impact, larger halo. But what you'll see is that you'll see a second part of this kind of lifting up, right? I think you'll see it right in this area, okay? So that is kind of a jumble. There you go. There it is. That is a big jumble that kind of just like lifts off and gives us at least 2 different solar storms that are kind of tangled together. Okay, this is why I'm going to kind of call it a train, not necessarily a chain or a series, but more of a train of solar storms, because these things are like linked together like cable cars. So we may be seeing a lot of junk when it finally starts hitting us. It's going to be just a mess. Are we going to be able to predict what these structures are once they hit Earth? I will be surprised if we can, because it's just going to be an absolute mess. More like a train wreck than anything. Okay, so that's the first set of storms. Those storms, they were launched on the 14th. They are slow, reasonably. So we had the faster one in front, but this tail filament is a much slower. It's a much softer, gentler lift. And so this thing is going to be one of the rate limiting steps, and is why the solar storm prediction model that we'll talk about here shortly is really, it was too optimistic in terms of arrival time. This is why the storms are going to be fashionably late, because we have several storms that are slow like this in the way, and they're not getting out of the way, okay? But that's the first set. Then, shortly thereafter, keep watching 3514, bam, right there. Did you see that? That is the X 2.8 flare, okay? This thing had, not only was it a big X-class flare, But in the largest of our solar cycle thus far, okay, just one check. Not only is it the largest solar flow that we've had of this cycle thus far, but it also had a really massive radio burst. And thanks to Mike Richardson, who is one of the moderators of the chat today, he actually told me that he was watching like antenna live television, and over the airwaves, not cable, but over the airwaves, and even the UHF VHF channels stopped. I mean, the whole thing just turned off. And so I went back and I took a look at the radio networks, and I'll show you those in a minute. We'll see that the radio burst went beyond 600 megahertz, okay, which is where those channels are broadcasting. So it was definitely, if you happen to be on the airwaves and you were actually watching live TV from an antenna, even if it's digital, it went out. And might have gone out for several hours because we had multiple radio bursts in there, and I'll just show some of those to you. So anyway, so this was an impressive solar flare because of the fact that it got up, possibly up into the gigahertz range, could have even had some GPS impacts because the frequency was so high. Anyway, so here's Nariaki Nita. I'm sorry I didn't put a nice credit to him, but Nariaki's part of the AIA team members. He actually did the EIT wave analysis. You can actually watch this massive blast wave. Look at that beautiful thing all the way across the disk. You can see because it hits mid-disk. We do know that this CME, the solar storm that was launched during this, is actually going to be not just fast, but energetic and likely going to graze Earth. So that was one of the cool things about that. Here's the radio blackout. Once again, a similar kind of showing of that EIT blast wave. And then here is where the radio blackout hit. If you were in the Western Hemisphere, and particularly in the Southern Hemisphere, we actually up here in what I call the Goldilocks zone in Canada and the United States, we actually got a less hit than the Southern Hemisphere did because it's Southern Hemisphere summer, so they're going to get the brunt of the radio blackout. But it lasted quite some time. And here are several different radio antenna networks that are basically going from in this case what was a 60 megahertz all the way up to 220 megahertz. This is in Mexico, and you can see the radio bursts. We had it, starting 7:15. You can see some stuff. Some of this is noise, but here's definitely the sun during that big X-class flare. And then we also had it in, whoops, let me go back. I keep hitting the wrong thing. Silly me. Where are we? Which one is this one? This one is, okay, that's Mexico. So let me go to the next one, which is there, Uruguay. Okay, and look at this. Up past 400 megahertz, guys. Okay, so, and strong, right? The impact, as you can see, it's not dying out up here. It's probably off scale. So I haven't had a chance to be able to check other antenna networks that are, because there aren't a lot of antenna networks that are in the Southern Hemisphere that go up that high on the ground, that have publicly accessible data, in real time. So definitely this thing went way up, possibly up to about a gigahertz. And then we also saw and this is in Roswell in New Mexico. Look at this. This is up past, this is 450, so this is 500 megahertz here. And you can see there's definitely energy up in this range. So definitely had radio bursts that was, and several of them that were quite large during this impressive period. And as we look at the geochron, you're actually looking at amateur radio contacts. These are FT8 contacts, and again, it's going to be the impact of this solar flare is going to be in the Southern Hemisphere. You can see as the flare begins to light up, there's lots of communications going, but watch as it continues. Look at this. It just completely cleared out all of South America. There's just no contacts at all. And in fact, if I go backwards a little bit, this is Andy Smith's from G7IZU is his call sign. He does these, are you going backwards or not? Okay, there we go. You can see from a slightly different database, you can see some of the DXing that's going on. Lots of contacts in South America, but again, as that flare hits, boom, look at that. I mean, absolutely just turns it off, and then it slowly recovers. Okay, and I'll back that up so you can see that one more time. And I'll stand out of the way so you guys can watch the whole thing. I have a tendency to get in the way, don't I? All right, so here's where the solar flare starts. Let's go. Boom, right there. You can see, look at all these contacts gone. And then it anneals and comes back. Pretty impressive. So over about 2 hours it took for for radio contacts to finally start really coming back to South America on certain frequencies. So HF radio is definitely feeling it. Again, the fact that we're in Northern Hemisphere, we're not feeling it nearly as intensely as they are in South America right now because of the fact that it's our winter, right? And we don't have as strong a look at the sun. Okay, what do I have next? Now, getting back to the sun, okay, so after that particular event, and I'm going to let that play so you'll see it again. After, that's the first one, there's the solar storm that lifted there. That was the X-class flare once again. Now, not just did we get a radio burst, a big radio burst from that, and solar radio blackout at the R3 level, but we also got a big solar storm launch. And sadly, because we had a big data gap in SOHO LASCO, I have to go to stereo. This is stereo A. Imagery to get the beacon data so I can see the halo. And you can see there's, again, a big halo. And in this case, it's a bit more of a halo, but we have to be a little bit careful because stereo is not quite at the same location as Earth anymore. But do we think we're going to get hit by this solar storm as well? Yes. And this is the one really that's driving, you know, if there's any speed impetus of this whole solar storm chain, this is the thing that's driving it. This is the sledgehammer that's going to squish together and pound together all those other solar storms in front of it. So, and if you recall, these solar storms don't cannibalize each other. They don't eat each other up, but they do compress each other, right? They get hitched to each other and compress each other quite a bit. So expect when the solar storm, when the front end of this thing ends up hitting us, it's have swept up all of those other solar storms in front of it. And so we're gonna get walloped hard. Even if this thing if the magnetic field orientation isn't the right way to give us a lot of aurora, when it hits, we'll get a big burst of aurora up front because it's just going to ring the Earth's, you know, magnetic system like a bell right away. And then things may dissipate if the magnetic field orientation isn't correct, okay? So a caution is that just because you see a huge jump in everything right away doesn't mean that's going to last, okay? We're not going to, and if you're wondering why NOAA SWPC has only put out a G2, what is it, a watch right now, or a warning? I always forget which way it goes. But it's the long look where there's like, okay, we could reach a G2. If you're wondering why they're not putting out a G3 or a G4 for this, well, part of it is because it's just going to be, you know, more of a grazing passage than it really is going to be a full direct frontal hit. But we are very aware that because there's so many storms up front and because this thing was moving so quickly, we could get a real strong compression region at the beginning of this set of solar storms, even if the thing begins to kind of fizzle out on us. So is this going to be as intense as, let's say, the last storm we had that got us to a G3? Probably not, believe it or not. Even though it was associated with an X-class flare, just probably not going to get there. Not to mention the other solar storms are slowing this fast puppy down. So, you know, when you slow something down, well, that doesn't have quite as big an impact overall. So yeah, a lot of compression early on, but then probably some fizzling out as time goes on. Now, as we continue this, so as this hopefully continues playing, that we have that solar storm, and then as it moves, we get yet another launch. Let's see, is that where you get, boom, right there, another M-class flare. Okay, and as we show the solar storm coming from that, we're back to stereo, we can actually see yet another big halo, okay, partial halo. So is this one going to hit us? It could graze us, okay, and it's on top of everything else, right? What's one more added to the mix? And then as we continue, I think this is when it's going to go pink on me. Yes, okay. So now here's the interesting thing, okay. So how many storms is that? Is that at least 3, maybe 4 now? How many have gone through? Now I'm going to take your eyes a little bit away from this area, and I want to put your eyes on this coronal hole. I want to put your eyes on this filament, especially up in here, okay, and region 3516, okay, because what you're going to see is some reorganization. You're going to get some small solar storm that goes off on the limb over here from the regions that haven't come into the sun's view yet. But then you're going to see this really kind of puffy weirdness change. You're going to see a little dimming in here, so it's going to get darker. You're going to see a little brightening up here, it's going to get brighter, and then you're going to see a boof, a little solar flare from this and some dimming in here, okay? What you're seeing is a stealth CME. Okay, let me play this for you, see if it shows up very well. And I'll rock it back and forth if I can. So watch it. Okay. Oh, no, wait, hang on, I gotta go back. Let me go back. Come on, go back, 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 back. Boy, it doesn't show very well in this. I'm looking for it, it's hard to see. So you see just a little bit of something in here, a little bit, there's a little bit of dimming. Yeah, I probably, oh gosh, it looked better. It definitely looked better when I was looking at it on my own system. But you see that little bit of brightening right there? Let me go back. See this? See that little bit of brightening? It just changes just a little bit. Right there, okay? If you go back here, you'll see this coronal hole shape changes just a little bit. This is why they're called stealth CMEs. Do you see right there? Look, do you see this? This dimming that wasn't here. See, right in here, there's not dimming. And then you go here and look, do you see that right there? Do you see how it gets darker? All in here, all in this little triangle area. See how it's darker here? Whereas if I go back, it's not. See? You see it really hard to see, I can tell. Okay? And you also get a little bit more change. Whoops, let me go back. You get a little bit more change in this area too. So I'm going to step out of the way. But this very subtle reorganization of field and stuff up here is also connected to this guy. And so this begins to loosen up, begins to pull something here, and then it pop. And so there's some big reorganization that's kind of a global thing here that's got a stealth CME in it. I am sure of it. And it's, of course, around a coronal hole that's going to be sending us some fast solar wind. So guess what? We may get some fast solar wind here in a few days that's going to be enhanced because there's a stealth CME in here. Okay, this is something that is really easy to see during solar minimum, not so easy to see during solar max. Okay, so watch it. I'll leave it open. Watch the coronal hole change just a bit. See it right there, boom, and then boom. See that? I'll go back one more time. Oop, if I can make it go back. Go backwards. One more time, and then we'll look at the chronograph. You see, basically what happens is this little coronal hole opens just a little bit more right in here. Gets bright, this opens it here, and this opens in here. And then, so you see this, and then this. Okay, I'll play it one more time. Here it's opening a little bit more, and then boom. Okay, now this, whoop, let me play it a little bit longer. There we go. Do you see this? This whole thing? Do you guys see that? That is what I'm concerned about, is going to be enhancing that fast solar wind when it reaches us. Okay. It looks like this structure, because it's just going to be moving out with the solar wind, this structure is not going to be hitting us full frontal. It's mainly going off to the east of Earth. But it definitely has, especially with this little guy in here, which hasn't really been imaged very well, this little filament thing that erupted, that's going to give us a little bit that's more Earth-directed. And this being a bigger halo, right, because it's going around in here. Most of it's going north, and that's because this filament, the main structure, went this way, okay? But there definitely a global reconfiguring that's given us this, really wispy halo. It's kind of surprising to see it. But that was the stealth CME that's in here. And so it's very common that these structures, once they reach Earth, if they get caught and squished in what we call the stream interaction region, they will enhance that stream interaction region. So this is going to be the chaser, okay, like a fast wind chaser at the end of all of this solar storm train. And I'll show you that as I get to the 5-day outlooks. Hopefully that was reasonably clear. But this has not been modeled, okay? And I don't know if it will be, because that's a pretty tough one to model for anybody. All right, so now let's talk about our solar storm prediction model. This is NOAA's version of the model. In this case, the top panel's density, the bottom panel's velocity, and you're looking down at the sun from the North Pole, Earth being off to the right. You can see it right there, okay? And as we put this thing in motion, you will actually see the solar storms being launched. Can you see them here? Right, there's one of the fastest ones. There was one slight in front of it. So they're basically modeling the two largest solar flare or fast CMEs that came out, fast solar storms, sorry, that came out with these that came out with the big flares. So this one in front is the emerged version of, and I'll back it up a little bit, because you might be able to see as it comes out that there are two, there's several in here. There may even be 4 in here. NASA did one that had 4 in it. I don't know how Tony did it, but he did. He's a great job. And then you can see the second one coming up like this. This is the one that's going mainly to the west of Earth. So as these merged, and in this case, in this model, these things merge together. In real life, they don't merge together. The magnetic field won't let them, but we can't model the magnetic field in these structures. Otherwise, we'd never get the model run done in time to have it be actually a forecast. It would come too late. So ignore the fact that they merge together. Just use it as kind of a proxy for this big jumble of train of solar storms coming. As they come, there's definitely a part that's going to be hitting Earth. Well, they were hoping that it was going to hit Earth, if I back it up just a smidge, around 1500 UTC today. Yeah, it's not happening. But as I mentioned, the reason why it's not happening is because we've got those slow solar storms in front of it. It's basically just dealing with traffic, right? When you get stuck in a traffic jam, you just kind of have to sit behind the cars and wait till they're done. You can push them, you know, and try to bully them a little bit and get them to move a little bit faster than they want to, but that only works so far. And so that's what that big storm is doing. It is definitely, you know, pushing against those other small storms, accelerating them a little bit, but likely not enough to get to a really big arrival time. But it does continue to compress it. So when we actually do get hit, the intensity is going to be pretty good. That's why you're actually seeing a pretty intense spike as these things pass over. Okay, and then afterwards, you're going to be having this, you can't really see it here because it's kind of broken now. The CMEs, the solar storms have ripped right through it. But this is that fast solar wind stream. And there's going to be a stealth CME in here. Okay, so you're going to have a stealthy solar storm in here that's going to be on the heels of this. If we look at the velocity plot, here is the speed from the big jump from the big solar storm. Here is the speed from the fast solar wind. That's the chaser. And like I said, there's going to be a stealth CME somewhere in here. Okay, so we could see storming from the 17th through the 19th, really, especially at high latitudes. That's what I would anticipate seeing from this. Okay. So, and I put that up on my 5 days. All right, so switching to our solar storm conditions and aurora possibilities over the coming week. At high latitudes, we are expecting a major storm. NOAA is expecting a major storm at high latitudes with potentially about a 20% chance of a severe storm, okay? And again, it may not last all that long, right? We may get hit really, really hard and then things quiet down quite a bit. Then as we move in through the 18th and the 19th, we're going to be seeing probably minor storm conditions. I may be looking at this. I probably am boosting this a bit more than NOAA is. I know they're going to have their forecast come out here shortly. It may be slightly different than this. I'm thinking that at high latitudes, we're at least going to see minor storm conditions till about the 19th. And that's mainly because not just the storms, but we've got that big fast solar wind that's going to be enhanced solar wind because of that stealth CME that's in there. So I'm expecting G1 conditions at high latitudes. And then as we're going to get through the fast solar wind over the 20th, then things will begin to settle down, into the 21st. Things should be pretty calm. But look at that. We've got a really nice extended period of fast solar wind, or of storms and fast solar wind to give us some decent aurora over the next few days. And hopefully this is going to, I'll see if I can just tab to the next one. Okay. And now at mid-latitudes, well, we're still dealing with the same kind of idea. We have the big storm will be hitting on the 17th, which it's almost the 17th now, so we're expecting to see that. Also, we might have a little bit of ramping up of stuff because we've had a few solar storms, little wispy, narrow things, kind of puffy things that have been shot at us, prior to the big solar flare, because we're so close to solar maximum. We're getting those all the time. And so we could see a little bit of activity, ramping up even before the big storm hits. So just especially stay on social media if you want to know if the aurora that you may be seeing is from the big storm or if this big storm has yet to arrive, because right now, as far as I know, it hasn't yet. But we'll talk about that more in the deep dive. Okay, so minor storm conditions with about a 15% chance of a major storm. I'm holding that over through the 18th. NOAA may not do that. They may drop it a little bit because, again, It depends upon how they reconfigured their estimates, considering the big storm hasn't hit yet. And then as we move into the 19th, we're going to have that wind watch again. It's going to be that enhanced solar wind. I do think it'll probably pop us up to active conditions. I don't think it's going to be a big enough fast solar wind that is going to get us up to strong storm levels. I may be wrong. I'm going to give us about a 20% chance of hitting of reaching G1 levels. It really just depends upon how the magnetic field is configured with this the biggest solar storm that we're going to see. Remember, we are near the solstice, the winter solstice, so it's not like at the equinoxes we don't have that favorable condition so much. So solar storms have a tendency to be a little bit subdued compared to other times of the year. But we could stay active through the 20th and then settle down again on the 21st. I think things will finally be a bit calmer then, but we'll be talking more about that in the far side on the deep dive. Okay, so let me switch now to solar flare and dayside radio blackout outlook over the coming week. Well, we are dealing with region, 3514 right now, and region 3516. They also have, that region also has a little bit of flare potential. We're sitting at about a 55% chance of M-class flares at an R1 to R2 level radio blackout, and then a 25% chance of X-class flares at an R3 level radio blackout over the next 24 probably to 48 hours, because that region 3514 is rotating to the sun's far side. So that's only going to last for a very short while, and that's why you're seeing the solar flux that's sitting in the mid-140s right now. That will drop probably to the 130s. Maybe a little bit lower. It's hard to say. We just have to depend. It depends upon what these regions are doing on the far side. There are regions, a set of regions we've seen before. It's another cluster of regions, just like I talked about before, that has something. We're seeing a lot more of those clusters than we saw, let's say, in the previous solar cycle. So it's kind of hard to know whether or not they're going to stay, active and continue to grow, or if they're just going to turn into these plages that just don't really give us all that much. So I'm being a little bit conservative and saying, well, maybe we'll dim down, but perhaps not. We'll just have to see. Expect moderate noise on the bands easily throughout this week. The radio blackouts will calm down just a little bit at least, but we will be still seeing a bit of noise on the bands no matter what, because we do have more regions rotating into Earth view, and they shall be expected to be pretty noisy. So just deal with that. If you get too upset at it, just go to the night side of Earth and give yourself a break. Of course, after these solar storms hit, once that calms down, then things will be better. Okay, now let me see if I can switch to radiation storm and polar aviation outlook over the coming week. We are sitting at elevated levels right now. We're sitting at the D2 minor range, and this is at flight level 360 for you aviators. We're below the S1 level now, and that's likely going to stay. I don't think we're going to get another big X-class flare from region 3514, but because we don't really know, we could still get one. We've got about a 30% chance of an S1 to S2 level radiation storm, and that'll be over the next, oh, that's interesting, what happened? Over the next day or so. Sorry about that. Over the next day or so. And then it will go to about 20% and then down. Things will go back to basically very low radiation storm risk, because that region is really the only one that's giving us a run for our money right now. And then, of course, as the solar storms pass, then the elevated levels, they will die down, and we'll be back to the quiet range probably by the 19th. But expect to be dealing with elevated radiation storm levels over those next couple days, even though we're below the S1 level. It's because we still have shocks, and we still have a lot of stuff in the solar wind that's continuing to drive those storm particles. So that's going to continue to happen. So frequent flyers and air crew and high-risk passengers, especially if you're flying over the poles or you're doing those long-range, intercontinental flights, please take this into consideration in your flight plans and check the ICAO advisories quite frequently. Okay, and that, I believe, is about it for the BLUF, for the bottom line up front. I will pause and take questions from you guys before we go into a deep dive, and see if there's any questions on what I presented for you thus far. The wind will affect, oh yeah, and you know what I forgot to do the moon. I'll do the moon in the deep dive for you, but we are coming close to a new moon, if I recall. So it's going to be great aurora hunting. We should have very little competition from our moon. Okay, let's see. Let me check Patreon to see if anybody's asked questions there. And forgive me if it begins to echo again, the silly thing. Okay, don't play. Good. Does anyone have a speed estimation for the fast CME from yesterday around 7 hours and 20 minutes? That's Julian. You mean Julian? Do you mean 7:20 a.m. UTC? Hopefully you're in the YouTube chat. Let me know. Is Julian in the YouTube chat? Hopefully, Julian, you are. If you're not, I'm going to assume that's UTC. I will go ahead and do that in the deep dive. Okay, if you're looking. This was the 15th at 7:20. I'm trying to remember which one that is. That's the second one, isn't it? Yeah, 7:57. So that's this guy. Let me play it a little bit. So this one. Does anyone have a speed estimate for that? That one is actually slower than the X-class flare, believe it or not. But it did have a very good halo in stereo, and I could go look up in seeds to see or in Donkey. That's probably better, using a real human as opposed to an algorithm. The M2M has they have a very nice database, and they actually do lots of analyses. So let me know, Julian, if you want me to do that. This one, however, is probably going to just graze us. This is the one that is, that's just barely. Well, if it's going to probably enhance the speed, enhance the pushing of the big X-class related solar storm that we got back on the 14th, but it'll help the pushing and help the compression. But I don't know if we're going to be experiencing this one directly, because it is so far to the west. Several of the runs show that we get just kind of a barely there impact from it. So hopefully that at least addresses that question. Oh, yes, I see, Julian. Yes, you said UTC. Yeah, Julian, let me know if that addressed that question well enough for you, okay? And yes, Silver Phoenix, yes, we got the echo. Anyone else hearing an echo? See, I can't listen in while I'm doing this, so I do rely on you guys to help me out. And yes, Lourdes, thank you for giving me a call. I knew you were calling about the echo, so yeah, I solved it. Okay. Oh, Lourdes, you have to go. Okay, no worries. No worries. Have fun. Stay sane, you poor thing. Some people have, they don't like these geomagnetic storms and the radiation storms. They bother us. Okay. Spirit, you say, Tamitha, do you think comets can affect the sun, and if not, why? I'm hearing people say there was a sundiver. Yes, there was. There was a big sundiver comet. It looked cute. And I was thinking, oh, please, sun, don't launch a solar storm right in the direction of the comet, because everybody's going to think, look, the sundiver comet came into the sun, and the sun launched this big CME. These sundiver comets, I mean, you've heard about a mosquito on an elephant's petard. It's not, that is overstating the problem. Most of these sundiver comets, if they survive and not get shredded, okay, or burnt to a crisp, they don't even make it into the corona of the sun, to be totally honest. They burn up long before they could even plunge into the sun's photosphere. So, the idea that that's what's causing the reconfiguration of the sun's atmosphere to launch space weather phenomena. Space weather is driven from inside the sun. It's not driven from outside in nearly so much. People argue concepts of tidal influences and things from other planets and other stars, and possibly even the intergalactic magnetic field interacting with the sun's heliosphere, with the sun's magnetic field at the edge of our solar system. I would believe that kind of stuff, those large-scale perturbations, far more than I'd believe a comet, because they're just so tiny, and most of them, like I said, they don't even make it. They get shredded. Even the big ones. I mean, anybody remember? Wasn't it Ison? It was Ison, wasn't it? That just, you could see the poor thing getting just torn to bits in the solar atmosphere long before you would worry about it even touching you know, the surface of the sun. So, yeah, that's exactly what I saw. Yeah, that's what it looked like. But, you know, believe it, especially during solar max, the sun is launching on average about 8 big solar storms a day. Okay, that's just average, every single day. So for someone to say, oh, look, the sun launched a big solar storm because the comet hit it, when it's launching 8 a day, the chances of you having it look like the comet caused a big impact on the sun, the chances are high. But coincidence does not mean causality, right? Especially near solar max. Oh my goodness, it's just silly. So don't worry about that. Yeah, the comet was so cool, though. I agree. It was really pretty. I was like looking for solar storms. I'm like, oh, look, there's a comet. So I got to look at Sundiver. Anybody who needs to follow Sundiver Comets on Twitter and go to his webpage, because he's counted so many of them. And he's such a good resource for that. And really great guy, too. Okay. And yes, a scientist, so he is a card-carrying member. You can trust him. He's got some good pedigree. Are earthquakes affected by solar flares? I would say no by the solar flare. I would say, you know, if you want to argue a geomagnetic storm, potentially, because of you know, this is an active area, obviously, in fringe science. You know, you can see mechanisms by which they work by these GICs. You know, they're actually inducing potential into the ground. The issue that you have, though, is that the drivers, the geological drivers, are so much more massive. They're just so much stronger that you're never going to be able to quantify space weather's impact on, or any type of cosmological impact on geological, you know, seismic activity, without first understanding the geophysical drivers. Because then you have to, once you understand them, you can subtract them out and you can see what's left. So right now it's all speculation because we don't even understand the geophysical drivers well enough to be able to back them out and see what other forces remain and what other anomalies remain in the record. So I think it's great that fringe scientists are continuing to work on it. I think geophysicists in mainstream science, need to continue working on solving their problem, the main problem, which is the geophysical drivers, right? The geological changes that are the majority of earthquakes. And because we have earthquakes all the time, to say that one particular earthquake is being caused by a solar storm is kind of the same thing as saying a particular CME being launched on the sun is being caused by a comet. Right? It's just, you can't do that quantitatively, okay? But do I like the fact that fringe scientists are working on the space weather connection? Yeah, I do. But I think you're going to find it far more with inducing currents in the ground than you will have it be, you know, so it's an electrostatic or electromagnetic phenomena, because I think those have a larger chance of being actual forces, stronger forces than having solar flares basically lighting up the D layer of the ionosphere, because that's what you're dealing with the solar flares. You're not dealing with magnetic, you know, the electromagnetic changes are much more tenuous, whereas with geomagnetic storms, it's a little bit more physical and stronger. So that's my hunch, is that's where the field will go once the geophysicists are able to back out the main, you know, the quantitative, back out quantitatively the main, you know, primary drivers, and then you can start looking for the secondary and tertiary layers of forces and forcing of you know, tectonic plates and things like that. That's just my take on it. Okay. Is CERN activated for this? I have no idea. I would think CERN doesn't care one way or another what the space weather's doing. Yeah, I don't think you have to worry. You'd rather not have a power outage. This isn't even going to be close. So anybody who's worried about it being the kill shot or the, you know, micronova, or, no, come on, relax. This is fine. Our weakening magnetic field is not going to cause any issues for us. I promise. Okay. this is going to be, if we get some decent aurora, if this becomes a G2, yeah, we'll get some red aurora again. Whoa, big deal. We get that every solar maximum when we have big solar storms. Red aurora has been around forever, so don't freak out. Cameras are becoming much more sensitive. Their CCDs are seeing things our eyes never could. So we are seeing aurora all over the place and much, much further south than we've ever been able to detect it. And that has everything to do with the CCDs. It has less to do with the Earth's magnetic field changing, although there is a role that that's playing. Pretty soon, and I keep looking for it, I keep looking to see if we get equatorial aurora. I want to see aurora in Portugal and in Chile and in south of Hawaii. I want to see it coming from the other poles that are coming out of that South Atlantic anomaly. I am ready for it and looking forward to it because it's going to be a fun time to be alive. So don't worry so much. Our Earth has gone through these types of changes many, many times, and it's not something to be concerned about. It really isn't. Okay. The holes in the sun. No, the coronal holes, no, that's just a source of fast solar wind. So if I back up, let me back up a little bit. So if we just talk about this coronal hole, don't worry about it. It's not really a hole. It's just an area where in certain wavelengths of light, it's not emitting. So it looks like it's a hole. But if I were to show you different wavelengths, like if I were to show you 304 angstroms or 171, the hole would disappear. Be like, oh, what happened to the hole? Well, because it never was a hole. It's just cold. But scientists started conveniently calling them coronal holes, mainly because the field is open and it allows solar wind to stream out freely and allows it to stream out fast. And so, as opposed to these regions that are brighter and hotter, that's because we have field that's closed, and that means that the solar wind is kind of trapped. It leaks out as opposed to being streaming out. Okay. And so because of that, scientists called these holes, but it was, in a sense, it's a misnomer, and so it makes people think of problems with the sun. And this is completely normal during this period of the solar cycle. We're going to see even bigger ones during the declining phase. So once we get through solar maximum, we're going to see big ones that go all the way across the sun, and it looks like the sun's splitting in two. Don't worry, it's not. It's not at all. It's just how our solar dynamo works. Okay. So we ain't going to be watching the show anymore when it happens. Oh, we're talking about those micronovas and no, guys, come on, please. It's just weather. It's just weather. Okay, we've lived through far worse than this. Trust me. In the 1950s, this is something I was going to get to in the deep dive. Okay, so I might just do that here soon. We saw, since we're kind of beginning to get into it. Let me back this up a little bit again, so you can see, right, this cluster of regions, okay? Right, so I've got this neat cluster of regions here. When did we see that? We've seen that recently, haven't we? Wasn't there just like a bunch of news articles all over the internet just like 2 weeks ago? Yeah, there was. Why? Because we had a different set of another set of clusters of regions, and they're just popping up all over the place. And what they're doing is they're just kind of, you're just having lots of magnetic, I should be careful how I say this. We're just having lots of magnetic field bands that are popping up because there's areas where they're buoyant, where they're getting twisted up, and so it's causing them to kink up, and they're actually popping through the surface, just like submarines popping up to the surface. And so there's a lot of, and there's likely lots of Rossby waves going on underneath the sun, which is part of how all this stuff bubbles up to the surface. But you're getting lots of different, basically these submarines, these sunspot clusters emerging underneath each other, which makes them very unstable, which is why these things go. It also lights them up like a Christmas tree. So we're getting lots of solar flux. So things are getting very, very bright. And the last time I saw this kind of clustering, when I was actually doing some forensics, was when we were in much, much more active solar cycles. And it was very interesting as we were on our way, believe it or not, we were on our way to a grand solar maximum. Back in the 1950s, we had lots of big clustering active region groups like this. And even though, I've been doing this for, I've been in this field for 25 years. I can't remember. I've been doing this for quite some time. I've been staring at the sun either directly in real time, or I've been researching the sun since cycle 19 and 20. I mean, that's where a lot of my research was done, was cycle 20, 21, and 22. And then I had to go back and do, even earlier cycles. So when I go back to like cycle 19 and 18, and even, excuse me as I get a napkin from my nose is running. Even as I go and I look back at some of these earlier cycles, back in the 1950s, that was a really cool time because some of the cycles were quite large, and the radio noise coming from the sun at that time was so intense, it caused radio astronomers to say, why don't we study the sun? It literally was the birth of radio astronomy, solar radio astronomy, because we had these radio antennas, and they were just off scale. We were getting so many very, very intense, up to gigahertz level. We were able to measure gigahertz back then, believe it or not. We just didn't use that frequency. But they were measuring these incredibly intense radio bursts back on the sun in the 1950s. And we had a lot of the same kind of clustering, where you had lots of little tiny sunspots, not just like a single big sunspot, but little tiny sunspot clusters that were just all over the place. So you had all the different numbers all over. And so it's really interesting to me because as I'm watching this, I'm going, we didn't have this in cycle 23, okay? I don't even remember a lot of this in cycle 22, maybe a little bit near the end, right? In cycle 22 was when we had, the Halloween storms. We had some superstorms there. And I just came home from AGU and I found out that scientists are talking about the April storm that we just had. I think it was the April storm, March or April. They're calling that a superstorm, by the way. They've classified that as a superstorm, being in a G3, almost G4 level. So we are back to having superstorms. I don't think we had a single superstorm back in cycle 23. And we've already had superstorms in cycle 23, sorry. So I don't think we had a single superstorm in cycle 24. And yet here we're not even at solar maximum, and we've already had at least one, if not two, superstorms in cycle 25. And we have probably the strongest part of our cycle yet to go, okay? So I find that quite interesting. And along with some of these sunspot clusters, it's beginning to be very amusing to me. And let's see if I might switch this over. My problem is I'm going to do the deep dive, as I do the deep dive and talk about, let me go ahead and switch this over. I talk about oh, goodness sake, what was I trying to say? Hold on one sec. I can't think and chew gum at the same time. Let me go to this. Okay, and now back here. I don't have these regions numbered. I didn't have time, sadly. But what I will do is I will pull up, because I'm on my different system here. So I'm going to talk about the JSOC helioseismology stuff here in a sec. But what I'm about to talk about is this set. As you can see on the sun's far side, they got pretty intense. That's that cluster that we saw just like not even 2 weeks ago. It's about to rotate back into Earth view. In fact, let me go to, somebody would go to Space Weather Live. If you don't know this site, you really are missing out. Space Weather Live is so wonderful because they let you do forensics. They have archives of everything, okay? So calendar is really, really nice to have because it lets you go back and take a look at all of the different stuff. So in this case, we're going to look at sunspot regions. Okay, and I might go back even a couple days prior to that. So, why are you here? Okay. So if you notice, look at all this stuff. Let me go back even a day prior to this. Let's go back to, yeah. Do you see what I'm talking about? Clusters, okay? This is the grouping, look at this, clusters, right? Really close together, okay? We're seeing more of that, where we're getting several regions clustered together instead of just single regions, okay? This one, when it first started out, right, it emerged on the east limb, and there were like 6 different sunspots all in here. And as it rotated, and it was firing off some really crazy stuff at the end of November. And as it rotated about here, it stopped. It just kind of petered out. We had such high hopes for this set of regions. And it kind of petered out. But then as it got to the west limb, as it got here, it got a little bit more active again. So I don't really know what this set of regions is doing. But as I go, on the sun's far side, but as I go to here for a moment, that's this set here, okay? So 3492, right? 3490. I wish I could keep these both up at the same time. 3490, 3492, 3502. And then the other set of active regions that was super, super busy was 3500 and 3501. Okay, so I'm going to go ahead and play. So here's 3501, 3500, and 3501, 3490, 3492, right? You know, that whole cluster. And this is what's transiting the far side right now. Okay, so as we're waiting, and I'll show you the helioseismology far-sighted viewer, that's the stuff that we're really watching, okay, as it's about to rotate into Earth view. And then after that, we're going to get a little bit more of a dead zone, but we do have a few more regions that are going to be rotating into view first. Okay. And where's my movie? This is the JSOC helioseismology far-sighted viewer. And there's those cluster of regions. That was back, they were moving to the sun's far side back on the 6th. Okay, and so now they've been on the far side and they're transiting. As you can see, they're staying strong, this cluster. Okay, so is regions 3500 and 3501, I believe, which is this set here. And just literally just about to rotate, and I wish I could pause this, but I can't. Just about to rotate back into Earth view. And for those of you who are not familiar, like wondering what is this gray and black and what is this thing? This is what we call a synoptic chart of the sun. Okay, and because we only have eyes on, you know, from Earth right now, we can't use stereo right now because stereo is not on the sun's far side. It basically has a very similar view as of the front side of the sun, just like we do. We have to use helioseismology to sound the far side of the sun kind of from within. So we ring the sun like a bell, and the sunspots ring in a slightly different way than non-sunspot areas. So everywhere that's gold is the far side of the sun that we're using HMI. We're using this seismic, you know, sounding of the sun to see where, I don't know if these are nodes or dead spots, but the sunspots don't ring the same way. They don't resonate the same way that that just the rest of the sun would. Okay, so when you see this thing moving, tick, 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 it's because the sun is rotating, and so our field of view, right, which is the gray part, that's why everything's so much better resolved in the gray field of view. That is changing as you look at the entire map of the sun, right? They took that round, the globe of the sun, and stretched it out into a flat map. So you're seeing both the front side and the far side of the sun, okay? So, but the sunspots, from this perspective, the sunspots don't change, they don't move. They just kind of grow, rise and fall like, you know, like submarines, coming up to the surface and then periscope up, right, looking around, and then dropping back down below the surface. So that's how they evolve, but they're not really moving, okay? So when you see sunspots disappearing on the limb, because this is the limb, this would be the west limb of the sun, and as you can see, as days go by, right, as days go by, that what is being viewed changes, okay? So right around the 30th is when these, well, the 1st or 2nd is when these regions went behind the sun's west limb. And that's what they've been doing ever since. They're about to, as you can see with that east limb coming over, see they're about to rotate back into Earth view is about the 15th. Ooh, they're almost in view, okay? So when we take a look at the sun right now, it's that cluster that's literally rotating into view. And we've had, from some of these regions, here and in here, we've had a few big solar storms being launched, okay? So is this set of regions continuing to be active? Yes. Is it another cluster? Yes. So we now have two big clusters on basically each side of the sun, because as we look back at our you know, current sun, the cluster of regions that we have now, which I'm going to see if I can make out, is this cluster right here. This is the cluster. This is region 3515, or 14 rather, okay? But of course it reset, but just give a second. So when it comes back into Earth view, hold on. Okay, on the 4th or so, that's when, see, look at these regions growing. This is the set of nasties that gave us the X-class flares and all that stuff. Okay, there it is. There's region 34 or 3514, is that the number? That's about to rotate off of the sun's west limb. So that set of clusters, that clustering active regions, along with a different set okay? We've got two big sets of these clustering, regions that we haven't seen in an entire solar cycle, which tells me that solar cycle 25, the one we're in now, is definitely a stronger cycle than we saw in the previous cycle, and it has hallmarks of some of the rising cycles to another grand solar maximum, which will be very interesting if that ends up happening. Too bad none of us will live long, well, maybe some of us will live long enough for that. I may not, because it may be another, about 3 or 4 solar cycles, but until we get to the peak, if this is going to be another grand solar maximum. But it's interesting seeing these clusters again. And so are we going to expect more X-class flares? Yes. Are we going to expect more radio bursts? Yes. Are we going to expect more big solar storms? Yes. Are we going to expect more Carrington-class events? Maybe not. Okay? Maybe because the bigger solar cycles are the ones that have less Carrington-class events. So we may actually be lowering our risk for Carrington-class events. We're just upping our risk for a lot more extreme events, right? Just not the super, super extreme ones. So it'll be very interesting to watch how this cycle unfolds if it continues to give us these big clusters of regions. And arguably, there's always good and bad when it comes to space weather, but arguably these clusters of regions are going to give us more trouble for satellites, right? For all our satellite assets, because we get these radio bursts that are high frequency. And so we rely so much on our space assets anymore that are chirping, those crickets near the train tracks, right? They're chirping at really high frequencies, but the sun is that train, and if it wants to scream at those frequencies, it will drown out those crickets until the train stops screaming and it goes away. Then you can hear the crickets again. And so we're going to be dealing with a whole different type of space weather than what we're used to, and that's going to be a lot more modern inconveniences when it comes to satellite communications and to the ground, and and radio, because we just use so much more. I mean, internet a lot of the times, right? We've got internet, we've got GPS. A lot of things rely on GPS and GNSS, a lot more than it ever has. And then obviously, if we're getting strong enough radio bursts that it's drowning out signals, television signals, as Mike Richardson pointed out to me just the other day, those are pretty intense. So it's going to be interesting. And even some airlines, you look on the Space Weather Prediction Center page, they're talking about some of their aircraft, the National Weather Service aircraft units were reporting outages during the big, the couple hours of that X-class flare the other day. So we're going to be seeing more of that. ADS-B, anybody? We're going to have problems because that transponder frequency is right at about 1 gigahertz. That's easy. That's easy peasy for the sun. Okay, so just be aware. Maybe less of a risk for Carrington-class events, but a bigger risk for stronger radio bursts and more extreme events. More frequent. Okay, so just get ready to expect to see these big storms, and these space weather is going to stay in the news for quite some time. At any rate, this stuff is coming within the next couple days. Okay, and then region 35. Let me get back to. Come on, minimize. Oh, come on. Let me get back to this for a sec. This set of regions. Let me go ahead and play this again. Wait till it starts over. This set of regions, which was active even on the sun's far side, this set of regions will be rotating in about 4 days. It'll rotate into Earth view. But those set of regions, the other set of regions, that cluster is rotating into Earth view now. Okay, so expect to see it on the east limb. We're looking at this as if this were our far-sighted sun, right? This was actually Earth-sighted sun about 2 weeks ago. But right now, this is what our far-sighted sun looks like. And so everything that here is on the west limb, if you're looking at Earth from Earth's perspective, which is being, on the other side of the sun, it's going to look like it's coming from the east limb. So if I switch back over to our our Earth view of the sun, you'll see lots of bright stuff on the limb in the east. Okay, it'll be on the other side, and that's what's coming around the bend. Okay. So amateur radio operators expect more radio noise. Maybe it'll calm down over the next couple days, and then it'll pick right back up because of these other regions that are rotating into Earth view. But it's still going to be a noisy week for for the radio bands, the Dayside radio bands, okay? GPS users, you as well, you're going to have maybe even a bigger deal because with the solar storms, you're going to have issues anywhere near Aurora, you're going to have issues near dawn and dusk, and you're going to have issues on the Dayside. So you're just going to have to kind of tough it through this upcoming week. Also be sure to calibrate your magnetometers often during the solar storms because there's a lot of drift, and you definitely don't want that to impact your performance and your safety. Okay. So, any other questions, guys? Oh, thank you. That's kind of you. If you haven't hit like yet, get to it. Her passion and knowledge deserves so much more than that. That's so sweet. Thank you, Axe. I appreciate that. We make it through this time. Yes, problems, but we can deal with it. Right. It's not an extinction event. Not even close. Oh, my goodness. It's weather. Can you imagine if every time a rainstorm were forecast, people would think they were going to die? I mean, that's kind of the way people are with space weather. It's just silly. Guys, these are the space weather equivalent of rainstorms, okay? They're minor inconveniences. Take an umbrella, right? If your foil hat makes you feel better, take it. You're not going to need it, but, you know, have fun. Nonetheless, it's just weather. And we got to get away from the panic mode. You're going to have a bigger chance of dying of a heart attack from being stressed out about the fact that there's a solar storm. Now, is there a biological component to it? Yes, there's been a lot of work done in this area, and solar storms, especially the geomagnetic storms, do have a very minor impact, and so that ends up exacerbating people who have comorbidities, or if they happen to be of the highly sensitive class because they've got things like metal poisoning, you know, plates and screws and bone and stuff, you know, or from surgical implants, or they've got devices that they have to use for medical conditions that are implanted in their bodies. Those people are more susceptible, okay, and so that wreaks havoc on your body. But the last thing you want is to be stressed out about a micronova or a kill shot at a time that, you know, is already stressful for people. Don't work yourself into a panic. It's so not worth it. Just relax and enjoy the aurora. I'm not even sure that the NERC and the FERC, if we don't even reach a G2, the grid managers aren't even going to care. Okay, if this is just a G1 level storm, which is completely possible, they're not even going to care, right? Matter of fact, let me switch back to show you the 5-day outlooks. That's a good place to end. I'll put it on the Mid-Latitude 5-day outlook so that you guys can see. It's just, you know, we're not forecasting a big deal here, right? I mean, look at this. It's G1 level, okay, at mid-latitudes. It might be a G2 at high latitudes. If we make a G2 at mid-latitudes, I'll be thrilled. You know, the grid guys are going to go, grumble, 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 because it makes them work a little harder, but there's not really an impact to the grids. You have to really get up to a G4 or G5 level, or you have to get to a sustained, you know, maybe a G3 sustained might make grid people go, and then what I mean by sustained is like 24, 36 hours, 48 hours of solid G3 or higher. Then you can start seeing the grid operators sweat. But if you're talking 6 hours of a G, so this, when we look at KP, we're talking about 2 bars, okay? Because each bar is 3 hours. 2 bars in the red, at a G2 or G3 level, they're not going to care. They really don't. They can ride that out very, very easily. Okay, the kinds of storms that our sun is capable of sending us that we have lived through back in, let's say, the 1980s and 90s, okay, even the early 2000s, are far worse than anything we've seen in the past 20 years. I'm serious. So relax, 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 relax. Okay. Mike, Bart asked, why are chronal holes not numbered or otherwise uniquely identified? They are. Actually, you're making me switch back to my thing so I can show you. Hold on. Go back to this. They are numbered, actually. Let me show you. So if anyone wants to find that out, oh yeah, I got to look at the real-time solar wind too here in a minute. just to see where we are. So I go to NOAA, Space Weather Prediction Center. No, I don't need to go to, I don't need to do the solar wind again. Well, it's all right. Loaded it. Let me go just products and data. Anybody who wants to see it, go to the solar synoptic map. They draw these all the time. Okay, they're really handy, to be honest. Owen Spencer, Terry, one of my favorite people at SWPC. I love he does these. He's so good at these. Perfect, perfect. I'm so glad I was able to get Spencer's because he does them digitally. He doesn't just hand do them. He actually takes the time to do them up on, I don't know what tool he uses, if it's Photoshop or something, but he always makes really neat and clean ones. So you can see the coronal holes are black, right? They've got them black and they are numbered. Okay, here's number 82. That's the one that's going to give us some fast wind. Here's number 84, not so great. And what's this, 83? 83. And then you've got some numbers beneath them. The plus or minus sign tells you what polarity it is. So this is a plus. Looks like 84 is a minus. Okay. And if we were near the equinoxes, it would matter. The equinoxes, in fact, if we were near an equinox in the fall, like let's say if it was back in October, this would be a far more aurora-producing coronal hole than if it would be if it were negative. If it were negative, then we'd have to be in the spring for it to be a really decent, a helpful coronal hole. Because of the way the Earth tilts during the seasons, that also tilts our magnetic field. And as it tilts our magnetic field, it makes us handshake with the sun's magnetic field in a slightly different way. And sometimes you can handshake with the sun's magnetic field in a way that it actually enhances the aurora, and other times you can shake your hand with the sun, with the sun's magnetic field in a way that reduces the chances for aurora. Well, the plus in this case during the fall actually enhances aurora. But because we're so near the solstice, the solstice is it's neutral. It doesn't matter either way. So it's not really going to enhance it all that much. But this is the coronal hole that's going to be giving us some decent fast solar wind. And I forget what the smaller number on the bottom is. I think it has to do with the quality, something about the quality or something about the intensity of the hole. I forget exactly what that number means. But I think the higher the better, they know the boundary better or something like that. Or the intensity of the fast solar wind. I forget which it is. It kind of goes hand in hand. And I may be totally off, so sorry, Terry, if I completely butchered this. But you do. So you can see that the sunspot numbers are numbered. And then these are flare risks and proton risks. It's the same thing as you see here. This is for the whole disk, and then this is for each active region. So 40% chance of C-class flares, a 15% chance of is that right? 15% chance of M-class flares, and no real chance for X-class flares from this region right now. But yeah, and then I could go on about filaments and little other things, other cute little things that they have. But but this is the cluster that's leaving right now, right? So you can see what a nightmare this cluster has been, and that it will likely be something we are watching on the sun's far side, because that cluster might do exactly what the cluster is that's coming, right? So we have a cluster that's just beginning to, you're seeing a little bit of it here, 3523, 3524, they may be part of that cluster. So as it rotates into view further, we'll see more or less what's going on. But it's really hard. You're going to have to give us a couple days, or give SWPC a couple days to allow those regions to rotate into view to get a better assessment of what the flare risk might be for them, because it's really hard to tell on the limb. Okay, and they have been very active, especially down here and up here. There have been regions just on the far side that just recently launched a couple big solar storms and flares. So they may be a little quiescent. We'll just have to see. It's hard to tell, but hopefully that answered that question. Okay. Oh, Les, thank you. Merry Christmas. Merry Christmas. Okay, so what I'll do, let's see, I'll look for any other questions here, and then I'll check Patreon one more time. This is your first, James, this is your first one? Oh, good. Well, welcome. Carrington rotation. Yeah, they call them Carrington rotations. A Carrington rotation is just simply a full rotation of the sun. Carrington was a scientist after all, right? So just because the Carrington event was named after him, that doesn't mean it has to be the only thing. Carrington rotations, we also call them synoptic charts. It's just basically taking the full globe of the sun and rotating it into a flat map. And so you have 27 days worth of you know, a full sun from Earth's perspective, because we can only see so much. And it takes a full 27 days for the sun to rotate fully all the way around, so we get a view of what the whole sun looks like. I can't wait till we get stereo back on the far side of the sun so we can actually view both sides again. It'll be nice. We're beginning to. Yeah, Smith and Lesson, Smith and Lesson, cute. The last G5 was a 2003. Yeah, yeah. That was when we were just beginning to drop down into that solar, into the grand solar minimum that we've been in for a little while. And no, grand solar minimums don't mean sunspots go away. It just means activity dims a little bit. You have to go into a deep grand solar minimum in order for the magnetic field strength and the activity to die so much that the sunspots go away. And in a sense, they're not really going away. It's just the same activity, but it's just the sunspots aren't buoyant enough to pop through the surface. So you're still having all that same activity going on. The dynamo is still churning. It's just not having any visible surface manifestations. And so therefore a lot less space weather too, right? Not completely none, but less, because a lot of space weather comes from sunspot clusters, not all of it. So, you know, again, there are certain things that people worry about, like, oh, our dynamo is dying and all that. Don't worry about that stuff. That's just, it's not, that's all myth. It's all it's just too much fear-mongering. Our sun is just fine. Tell them when the full magnetic reversal with the sun happens and how often. Well, we don't even know, to be totally honest, we don't even know if we're having a magnetic reversal. Geophysicists have seen this kind of dip before and a recovery. There have been multiple times in our historical record that we've had dips of this magnitude and even deeper. And then it just recovers. There was not even a dipole flip. It stayed the same. So what we're seeing with the South Atlantic anomaly right now is, I've always made this analogy. Think of a bathtub filled with water, a soapy bathtub filled with water, right? And it's a kid's bathtub, so there's a bunch of toys on the bottom of the bathtub, but you can't see them because the water is murky and soapy. Only when you drain out the water do the toys begin to poke through the surface, okay? Well, if you think of the higher order terms of Earth's magnetic field, meaning the quadrupole field, the octopole field, and higher up, okay, because there are more, the dipole part of our field is not the only component. We've got other higher order components, they're just smaller. And so they're sitting quite nicely under the surface of the water, and you don't even notice them really, you know, to a 0th order degree. You don't really notice them until that water drains down, okay? And that draining, that's the dipole field component draining out, being, you know, reducing. And then you start seeing those toys, those higher order components poking out. That's what we're seeing with the South Atlantic anomaly right now. If anybody who's paying attention to it is noticing that it's elongating, and now we actually have 2 points, 2 poles, 2 minima inside that South Atlantic anomaly. Stretching out, one is moving kind of a little bit more upwards toward Hawaii and over South America, and then the other one is moving a little bit more toward Africa. And that, there you go, 1, 2, 3, 4. We have the North Pole and the South Pole and a you know, kind of an east and a west pole to some degree. There's your quadrupole. You know, you're seeing this influence from a quadrupolar, component. But it doesn't, other than having a little bit more aurora, other than reducing geomagnetically induced currents, which will be nice because our magnetic moment is going down, so you can't induce nearly as strong GICs. The power grids love that. Outside of that, you know, really the biggest question is going to be what's going on with particle precipitation. That's going to be very interesting. Airlines are going to have a fun time with this, and so are satellites. We don't even know if we're going to have stable radiation belts. I'm actually beginning to hunt around. I was having some chats with some scientists at the AGU. I'm going to be looking around to chat with more people about where the funding is for doing more serious analyses of what space weather will be and what the near-Earth environment will be. Because we got to know if it's going to clear out our radiation belts and if there are going to be any stable radiation belts at all. Or if particles are just going to penetrate and then penetrate into our upper atmosphere, and then we're going to be dealing with more cosmic ray showers. If we deal with more cosmic ray showers, my goodness, that may affect terrestrial weather. It's really a fundamentally interesting thing. But it's not necessarily, I mean, first of all, our Earth has done this before, you know. We've had this kind of thing before. And it doesn't, there's not a mass extinction event. Sorry for those doom and gloomers. It doesn't happen. And it's because we're not unprotected. Our atmosphere, even when, because I've actually read a couple papers on this, even when the dipole field completely goes away and we're fully quadrupole field dependent, that quadrupole field stands off the solar wind far enough away that our atmosphere is safe. Okay? It's not going to strip off our atmosphere. So don't worry about it, right? Scientists are working on it. There's just not a lot of funding on it yet. But it's going to become a bigger and bigger deal as more and more people become aware of the implications of a changing field. Okay? And I am beginning to see some papers, but like I said, I need to do some digging because pretty soon I think you guys are going to want me to do an actual mini course on it. Once I get through the Carrington class events, I'll probably do a mini course on it. Okay. Anyway, enough of that. The field is fine. and you know, again, we're not even completely sure that it is flipping, but if it is, we'll be fine. And our atmosphere will be fine. No one's going to die. Okay. If Aurora is at the equator, you can expect to grow your own food to stay alive. I don't know why you say that. It's not going to change. The only thing that's going to be a problem is that you might have precision farming be a little bit more tough because you've got GPS issues, because you've got Aurora now scintillating all the GPS signals. So there's going to be technological impacts that are going to be far more intense than, you know, human, you know, anything on biology, okay? And so those who are going to be dealing with it are going to be, and grumbling about it, are going to be people who are having to rely on GNSS services. You know, the Brazilians are going to laugh at us because they say, hey, finally you guys get to experience what we've been dealing with the whole time. Because Brazil, they have to live essentially under the South Atlantic anomaly. They know what this stuff is like, right? They deal with it all the time. GPS doesn't work, especially around 9 p.m., you know, just after sunset in the summertime. It just doesn't function. And they're trying to find ways of mitigating that. That's why there's space weather centers being set up in South Africa. If you're in Africa, in the African continent, period. If you go to Africa and you try to talk about space weather or look at it, you will find a totally different set of things that they worry about than what we worry about here in the Northern Hemisphere and in you know, Canada and the United States and even in Europe and that. They worry purposely, almost solely about radio communications, because that's what they have to deal with. They have to deal with a totally different kind of space weather. So if and when our field gets to the point where it's changing to that degree, well, the whole globe may be dealing with that in a manner of speaking, because we have more poles. And so the impact of particle precipitation, the impact of auroral scintillation, geez, the equatorial anomaly, who knows what that's going to look like? I mean, it's just going to be a lot wackier a place. And scientists are going to have an absolute ball because they're going to be able to discover all sorts of things all over again. It'll be like the golden age of space weather all over again. So it's a neat time. It's not a time to fear. Okay, we'll be fine. All right. All right, lady, any other questions other than the magnetic field? I don't want to keep going on it. How does the Mexico Gulf salt influence the sun's aim? Cute. I have no idea. 80 meters to Europe is open. Right now, at night, Jerry, it's got to be nighttime, right? For you, it's got to be dark over there. Yeah, it's dark over there. But that's good. I'm glad it's open. I don't think, if I look at solar wind right now, I don't think the solar storm is hit. Let's look. Nope. We don't have a big solar storm hitting yet, and I'll even look at ACE data. So, yeah, see, this is what I'm talking about by traffic, okay? So here's the solar wind speed, all right? This is the speed panel, and it goes from, for those who can't read, 400 kilometers to, what is that, 6? Yeah. It goes from 400 kilometers a second to 600 kilometers a second. We need, a rule of thumb is you need about 400 kilometers a second for it to be ambient solar wind that actually can give us aurora, where the aurora is going to drop down to possibly mid-latitudes. Look at this. we're sitting here at, what, 450 maybe? 450 kilometers a second. This is not fast solar wind. This is not the speed of a fast solar storm. This is the slow traffic that we're talking about. Okay, so this is what's holding up that big storm. And you can even look at the magnetic field strength sitting, what is it, even, oh gosh, it's like 7 nanotesla, for goodness sake. It's not much going on, guys. Some low-level stuff. Remember I said we had those little puffs of solar storms ahead of the big one? That's what some of this is. You know, I can see there's a little bit of southward magnetic field, which is nice. I don't think it's a flux rope or anything, no. Let's take a look at ACE. And the reason why I want to look at ACE is because I want to look at, oh wow. Well, it hasn't died off completely. So this is ramping up. Oftentimes when we have a shock wave in the solar wind ahead of a solar storm, you know, when you have fast solar storms, you have that. You can watch the low energy particles rise and rise and rise, and they'll rise to a peak. But we had a radiation storm on top of that, so that it kind of complicated the issue. But as I can tell, you know, it looks like, because you can see these lowest energies here, they're not dying off. Usually when the shock wave passes you, then they die off. They'll peak and then they'll go down. And as you can see, we actually did have kind of a peak. We have some data gaps here. But then the higher energy particles, you can see them ramping down, okay? But the low energy stuff isn't ramping down yet, you know, not quite. So it's hard to tell if that shock wave in front of that strong storm got slowed down to the point where it's no longer a shock. That could be possible. So we may be dealing with that really fast solar storm that we thought was going to hit us so quick, actually hit us at 400 or 500 kilometers a second, okay? We'll see an incredible compression of the solar storms ahead of it. But this is not, to me, this is not encouraging that this solar storm that's coming is moving that fast. Otherwise, these particles would continue, especially even the higher energy stuff, it would continue to go up, okay? So it's coming. It's just slow. It's been slowed by the traffic, just as, you know, just as I mentioned yesterday in the snapshot that I did, and just as I mentioned today, you know, you even saw it up on the, you know, when I put the NASA or the NOAA prediction up, and you saw the thing where I said that the prediction is the storms are going to hit later than they anticipate. This is the reason why. This is, you know, it's stuck in a traffic jam. It's late. Sadly, it's on the 405 in the middle of rush hour. So, you know, not expecting much. We're probably getting a little Aurora right now. Yeah, it's building. You know, we're sitting at I probably could look at the AE index, but, you know, we've got a little Aurora, according to the forecast. Not that much. Let me look at Kyoto real fast. Might have some substorming. Come on. If I can get it up. And then after this quick look, I'll probably wrap it up, guys. If this will load, hello, are you going to load? I don't know. Let's see, while we're waiting, any other questions, guys? Let's see. Yeah, Mike, you're talking about studying the sun back in, oh goodness, wonder what's wrong. Kyoto, we can't reach Kyoto? That's too bad. I'm not used to that place being down. Kyoto is usually rock solid. Huh. Yeah, it's not up. Oh, I don't want to have to look the AE index. Do you have a picture? No, you want me to go to Kyoto. I don't know if NGDC is gonna, no, I don't want to have to, no, you asked me to go to Kyoto. I don't want to go to the, yeah, looks like Kyoto's down. That's sad. Because there's a lot of people who could really rely on it right now. I usually rely on it. I guess there's one other way I could look for it. Hold on a second. There's another roundabout way that I can look for substorms, so give me a second. No. Yeah, I could look at magnetometers, but I want to look at GOES. No, nothing, not too much right now. We've had a few. So this is the GOES magnetometer. This is our Earth's magnetic field. And we've a couple of these wiggles show some substorms, but right now we're not getting, neither spacecraft are showing big bumps and wiggles, so we're not getting much substorming right now. It may be building slowly, but probably not a whole bunch of aurora right at the moment, sadly. But we are still waiting, guys. We're still waiting for that. Yeah, there's not much going on. We are still waiting for that solar storm to hit, so hopefully it won't be too much longer. If it's too much longer, then it's not going to be that strong. But yeah, all we can do is just cross your fingers. It is coming, so don't worry. It's not going to be a fizzle. We're gonna definitely get hit by some stuff because there's too much stuff that's Earth directed for it to miss us entirely. But yeah, definitely not a kill shot, not even close. So just enjoy. Okay, guys, let me check Patreon to see if any other questions are there, and then I think we will wrap this up. Hopefully you enjoyed this today, even with all my weird echoing. Oh, I guess I said, oh, the BBS, oh, this is interesting. Mike Wallace, you say the BBC News said that the aircraft lost communication due to the X-class flare. That's true. Do you know how bad the communication loss was? For several hours. So, Mike, if you're still there, the loss was several hours long. And let's see, Gary, you said, I have a ham radio program that displays current space weather. It displays the NOAA weather, space weather, and the fields RS and G. Yes. Currently, G is shown as the number 221. Oh, all I can think of, 221, that's weird. I don't know what that, all I can think of is that maybe several readings of the KP index. Because right now, we're sitting at a KP, we just jumped up to a KP of 3. So maybe those were 3-hour blocks of KP. I don't know. You'd have to look. But G is a scale that goes from 1 to 5, and so does the S and so does the R. So the G scale is it's the geomagnetic scale. That's the one that talks about geomagnetic storms. Basically, when the big solar storms hit, that cause aurora and cause power fluctuations and stuff, causes the geomagnetically induced currents. That's the G scale, okay? The R scale, of course, is for solar flares and the radio blackouts. But, yeah, I don't know what 221 is. So hopefully that answers that question. And, yeah, Mike, I would say that the communication loss was sporadic, but was about 2 hours. Lisa, you said, thank you, Tamitha, from cloudy Scotland. Oh, yeah, I've got to get a bigger fan to blow away the clouds. Understand. Jerry, thank you. Merry Christmas. And Joe, Merry Christmas. And thanks for a well-needed update. Good. And Chris, you say, since Santa will be traveling below flight level 360 for most of the night, I don't imagine it's a big problem. But has anyone alerted the North Pole? And by the way, what is the maximum exposure endurance a red-nosed reindeer can handle? I am not answering those questions. I am not qualified. You must get a North Poleologist, a reindeerologist, a Rudolphologist to get the proper answers for those questions. That is way beyond my pay grade. Okay. Igno, you say, saw an article saying it was the biggest radio blackout since records began. No, I doubt it. Of this solar cycle, or if the records had only been kept for the last few cycles, sure. We had much bigger radio blackouts in the 1950s, much bigger than this. But I will look. I mean, I looked the other day for articles, and it was, I saw maybe 1 or 2 things on it, but they weren't really telling at all. And again, I'll try to take more time to dig into some of the radio astronomy records, but they're usually not the ones that have really high frequencies, where we can go up into the gigahertz range to see how high the radio burst is. those records oftentimes aren't ready for 24 to 48 hours afterwards. So I need to look back. I just grabbed the ones that I could get, you know, in real time, and you know that go up to like 500. You saw 500 megahertz, so half a gigahertz, and you could see a lot of energy up there. So do I believe this thing went up beyond a gigahertz and went into the L band? Absolutely. And once you go into the L band, you know, even low into the L band, like 1.2, 1.3, 1.4 megahertz, or gigahertz rather, satellite phones, GNSS, right? ADS-B transponders. I mean, you're talking about airline flights. In dealing with that, you're talking about anyone with a satellite phone. You're talking about drones. You're talking about you know, even precision GPS for landing aircraft. You're talking about all sorts of that stuff, and you just have to, you know, it just becomes very impactful very quickly. And in this case, we had lots of bursts that were kind of on off. I was noticing in the data. It'll be interesting to look at the higher frequencies to see whether or not that was repeated at the higher frequencies. Oftentimes, the higher frequencies have less, you know, so whatever was happening down at low frequencies, there's less of it at high frequencies. So we'll see if it was quite as sporadic. But HF radio definitely got hammered. So did VHF and UHF, right? Some frequencies in UHF. So, you know, I'll look, but it's definitely not the largest radio blackout on record. I can't imagine that. It just doesn't even look like it. I've seen bigger. Okay. Sure, a lot of hype out there. Yeah, I agree. Sounds like it would be some sort of red monitor for Rudolph. Yeah, right. Oh, that's so funny, guys. You guys are funny. It's good to hear a lot of levity during times like this, because there's just too much fear-mongering and doom and glooming. NASA are sending people back to the moon in 2025, right in Solar Max. Is that wise? Yeah, you know, sadly, you know, no, I don't think it's necessarily wise, but these things are always, the problem that we have is that schedules slip. You know, we can plan for one period and it ends up being somewhere else. Ends up taking years later, and so now we find ourselves in a different time. Also, anymore, with the way the solar cycles have been, with them being really low activity, our cosmic ray flux during solar minimum has been incredibly high. 30 to 40% higher than we had seen it during the grand solar maximum. So sadly, solar minimum right now isn't the greatest time to go either. That's the thing with space weather. You know, if you're not dealing with space weather from our star, you're dealing with space weather from all the other stars out there, because our star, when it goes quiet and hibernates, you know, during solar minimum, it doesn't shield out all the junk that the other stars send us. So, you know, space is a hazardous place, and there's always bad space weather. And it's just, how do you deal with it? And NASA and NOAA, well, NASA in this case, the prevailing theory is that they would rather deal with solar energetic particles from our star than deal with cosmic rays from other stars, mainly because you can shield for the most part, you can shield out the radiation storms from our star because the energies aren't quite as high. Cosmic ray energies are insanely high, and it's impossible to shield them out. So you might, if astronauts are disciplined enough to wear their, you know, radiation suit armor and sit in their, you know, coffins for the worst part of these radiation storms, which could be hours if not days. I mean, I think it's, anyway, the discipline it takes to be able to be in space and, you know, sit in a coffin for ever, when you know that you're being bombarded by all this radiation. It takes a psychological discipline that's pretty mind-blowing. But because you can do that with solar energetic radiation storms, solar energetic particles, but you can't necessarily do that with cosmic rays. I think that's why they would rather do it while the sun is active than when the sun is quiet. That's my guess. It's a trade space, because it's never good. Okay, it's just never good. But there's a risk either way. But I think that's the mentality. But don't quote me on it. It's speculative. There's a lot of pieces that go into why they do what they do, when they feel it's the best time. And a lot of times, like I said, the schedule slips so dang much that the safety, the space weather aspect of the exploration is only such a small factor that it may not get as a strong a vote, right? I mean, you have to go when the schedule allows. You have to go when the product, when the hardware is ready. You have to go when the funding is there. I mean, there's all sorts of things that all the ducks have to line up in a row, and space weather is just one duck. So if all the other ducks line up in a row and space weather isn't aligned, they'll go anyway. You know, that's just the nature of this kind of exploration. Hopefully that answers that question. Okay. All right, guys. Yeah, cosmic rays are a much worse threat. They can be. They can be. I mean, if you get we have had a potential lethal dose from, during in between Apollo 16 and 17, right? We had that one event, the 1972 event, that could have just been absolutely lethal for astronauts on the moon if Apollo 16 had been delayed or Apollo 17 had been moved up. So we can get those, and in that, yes, in that case, that was a Carrington class event. And those do exist, and they can cause, an unrecoverable loss, and they can be fatal potentially for astronauts, potentially. But they are rare. They're rare enough, but we know that cosmic rays aren't. You're bathing in it all the time. So I think it's just trying to statistically beat the odds, I think is really what it comes down to. Yeah, amazing mental discipline. I agree. Okay, I wish more people would watch your channels and forecasts because so many jump so quickly to conclusions about the X-class flare CME and think it will hit Earth just because it was X-class. Yes, thank you, Adrian. Just so you guys know, just for those of you who are still watching, this is not an X-class anything when it comes to the solar storm that's heading toward Earth. This CME, this solar storm, okay, I say both words interchangeably, right? It's not X-class, it's not M-class, it's not C-class, it's not A or B-class, it's none of those classes. Those classes are for flares, okay? Flares and CMEs are totally different things. Okay? You cannot equate one with the other. And just because you have an X-class flare does not mean you're going to get a monstrous solar storm. There have been many X-class flares where no solar storm is launched. So, decouple solar flares and solar storms. Decouple them in your mind. Take them off one side of the mind and the other. Do not consider an X-class flare as something that's going to give us incredible aurora. It doesn't happen, okay? And you need to, stop conflating these two totally different phenomena. And X-class flares they're 2 hours of your life on the dayside, if you're on the dayside, okay? That's all an X-class flare is. Sorry, 2 hours of your life. And, a solar storm is so much different, right? It can take days of your life, especially if you're an aurora chaser, right? And they could be the most rewarding days of your life or the most frustrating days of your life. Just ask any aurora chaser, and they'll tell you firsthand, okay? Radically different than a solar flare. So I hope we eventually nip that in the bud and people stop saying it. It's an X-class CME. Oh my goodness, please stop. It's just, once again, fear-mongering. Can you hear me, Major Tom? Very cute, Lou. Yeah. I'm a David Bowie fan myself, so. You're welcome, Adrian. Thanks, Dr. Scove. That's nice. Okay, guys, any other questions? Because I can tell my voice is beginning to fade. Thanks, Professor. You're this X-class forecast, and oh, that's sweet. The forecast in education, that's sweet. Thank you, Del. Okay, Gambaz says, would these events have killed the astronauts right away, or would they have been lingering? It's hard, it's scary to think, but they would have gotten radiation poisoning, right? And anyone who studied the, Fat Man and Little Boy, or was that a Fat Boy and Little Man? I forget. You studied the whole Hiroshima and Nagasaki nightmare, knows about how people died. Not a fun thing to talk about, but yeah, that's so it's probably the whole zoo. Some people may have died right away. Some people may have lingered, and other events then could have made it worse, or they could have just died coming home. It also depends upon whether they were in a spacecraft or they were out on the lunar surface. On the lunar surface may have been better, but now we're also learning about lunar neutrons and the neutron albedo, which you can't shield against. There's just all sorts of stuff because the solar energetic particles hit the soil, the regolith, and it liberates these neutrons that then radiate, are another source of radiation dose for these astronauts. And neutrons are displacement damage. They're heavies. They're bigger. So they, I want to say heavies. They're not heavies, but they just cause more damage. And so that's a whole nother biological component to being on the moon that we just don't know that much about. We just don't, sadly. So anyway, okay, yeah, we're going to learn, there's no doubt. All right, guys, looks like we're good. Let's see, here's Bob Ritter asks, can an X-flare light level be so high that it, where are you? There, that it would cause issues even with a telescope for solar use? Space telescope, sure, we've had it. We've damaged, look at the SXI on GOES, look at GOES 13. I actually was on a forensics, Tiger team forensics analysis that we did for GOES SXI. I actually had to write up what we called the SCAR report. And because it was the SXI corrective action review, so SCAR, S-C-A-R. Not because it scarred the instrument, which it did, but it was because that was the review of the anomaly, how it happened, how to prevent it in the future. It's a very interesting tale. But I was one of the leads of that team, and yes, X-class flares can absolutely do that. This was the December 6th flare that burned, absolutely destroyed the SXI instrument. But the nice thing is that if you're on the ground, don't worry about it, because our atmosphere absorbs all the X-ray flux. So you can't see. That's why the corona looks so different with space telescopes than it does on the ground. You can't see all that. You can't see the X-ray, and you can't see the extreme ultraviolet from the ground. Okay, so it'll never be a problem for ground-based telescopes, only for space-based telescopes. And so yes, we have lots of flare warnings and automated algorithms that are protective circuits and things that do certain things to the optics and change things and stop imaging and lower exposure ratings to protect the CCD from damage in all the GOES units. They're very well aware because they've been bit in the butt before. As Vic Pizzo told me, they got caught with their pants down. Yeah, it happens. It happens. Okay, so hopefully that answered that question. Oh, good, Joseph. You're a volunteer firefighter. You will rewatch it from the beginning. Absolutely. Love that's actually navy blue, not black, but close enough. Yes, watch from the beginning. Enjoy. The BLUF is at the front, and then we go into the deep dive, and then I do the big Q&A afterwards. I will be around, for those of you, when the storm hits, I will be on Twitter, and we will be monitoring the Aurora reports as they come in. And so I will be giving you guys periodic updates once the storm hits, okay? So enjoy, and don't worry. Just relax. It's going to be a fun time, okay? All right, guys, I'll let you go. Talk soon.